Dark matter is one of the more confusing theories in astrophysics. Nobody knows all that much about it, not even if it really exists. However, it has become quite the fan favourite. But recently, new evidence came out against it, so the question is this the end of dark matter? Firstly, what would dark matter be? Dark matter is thought to be a type of matter that does not interact with the electromagnetic spectrum, so any light, but does interact with gravity. This means that we could never see it directly with a telescope or whatever, but why we could see it interact with other objects like stars and galaxies. Kind of how we can sometimes see stars orbiting black holes, but we never actually see the black holes themselves, only the surrounding objects they interact with. But why was a theory of dark matter needed in the first place? It all started with Fritz Zwicky in 1933. Zwicky was observing 8 galaxies in the Coma Cluster and found that their rotation speeds didn't match predictions. But what were his predictions based off? This is a graph showing the rotational speeds of planets in our solar system compared to the distance from the center. It makes sense that the planets closer to the Sun orbit faster because the pull on them is stronger, as most of the mass is concentrated in the Sun. One would think that the same would happen with stars and galaxies. Well, one would be wrong. This is a graph showing the speed of stars relative to the distance from the center of the Messier 33 galaxy, which is a supermassive black hole. The prediction looks very similar to what we see happening with planets. The observations, however, are much different. Instead of having a dip as the stars move further away from the center, the curve seems to flatten out. The stars shouldn't be orbiting that fast on the outskirts of the galaxy, unless something else was making them do so. And this doesn't happen just in this galaxy, but in most other galaxies as well, including the Milky Way. Zwicky concluded that for these stars to be orbiting this way, there must be a greater gravitational force coming from somewhere to make them do so. However, there didn't seem to be enough matter to account for these gravitational forces, at least not enough luminous matter, which is matter that interacts with light. Hence what was needed was non-luminous matter, or dark matter. This is the gist of the theory of dark matter. However, the whole theory relies on our understanding of gravity. Dark matter is only needed because our gravitational predictions do not match observations. The galaxies are moving too fast to be accounted for by the visible matter. One solution would be to add extra matter to the mix, which is basically what dark matter does, but an alternative step would be to have another look at our understanding of gravity itself. One of the theories that does this is MOND, modified Newtonian dynamics. MOND doesn't really take into account Einstein's theory of relativity, hence the name Newtonian dynamics. However, Newtonian dynamics are a good enough approximation for something that accelerates as slow as a galaxy. What MOND does is it takes Newton's equations and adds extra terms into the mix, which makes the equation be able to predict the gravitational forces so they match observations. It also says that inertial mass, which determines how much an object will resist a change in motion, and gravitational mass, which determines how much an object will interact gravitationally, are not one and the same. But what does this mean? Well, in Newtonian dynamics, you can calculate how much you weigh just based on the interaction between you and the Earth. However, with MOND, your weight depends on all the other interactions happening across the universe. For example, how close Jupiter is to us that day. The key difference is that in MOND, a subset cannot be separated from the greater scheme of things. This is called the external field effect, or EFE for short. Okay, so if we have an equation that can predict what speed the galaxies will move at, why is dark matter still a thing? Well, there are a lot of problems with MOND. For starters, it predicts that gravitational waves do not move at the speed of light. However, a study on binary neutron stars has been done to confirm that they do. So problem number 1, there is some evidence against it. Problem number 2, it's more of an estimation rather than a solidified theory. Just on Newtonian gravity is a good approximation for the theory of relativity in the less extreme cases, MOND is a good approximation up to the point where general relativity is needed, and it also only really works for small accelerations. Ideally, we'd have something similar to MOND that can be derived from general relativity. This would be called the modified gravity theory, but it has not been created yet. Problem number 3, there is a lot of evidence for dark matter that has piled up since 1933. We can't just throw all that out the window until it has been proven that this theory is better than the dark matter theory. Okay, on to the thing you clicked this video for. Is dark matter wrong? Well, there is some new evidence that contradicts dark matter and is in favour of MOND, but what would MOND mean for the galaxies? Well, if MOND is correct and the external field effect exists, the speed of rotation of a galaxy would be dependent on the density of its surrounding area, i.e. how many other galaxies there are nearby. as the galaxy's inertial mass would be affected by the gravitational interactions with all those galaxies around it. So the speed of rotation would be dependent on how many other things there are around that galaxy. The key question is, does it? Well, apparently it does. A study done just last year that looked at 153 different galaxies has shown that galaxies found in denser surroundings were pulled at the outer edges by the galaxies surrounding them. This meant that the speeds at the outskirts were lowered because the stars were being slowed down by the pull. But the speeds of more isolated galaxies were more constant, as nothing was pulling on them to slow them down. This is evidence that the external field effect exists, and that supports the MOND theory. Though remember that evidence does not mean theory proven. In conclusion, is the theory of dark matter wrong? Maybe. Is the theory of MOND wrong? Perhaps. Do we actually know? No, we don't. But we're getting closer, and that's what matters in the end. Hi, this is the person behind the video. According to YouTube statistics, an undefined percentage of my viewers is subscribed because, well, this is my first video, so I have no viewers, and none of them are subscribed. So if you want to get rid of this division by zero error, you know what to do. Also, tell me how I did. This is my first time properly editing anything and doing voiceover, and it took ages. And give me any tips if you have any, because I have no clue what I'm doing. I'm just having fun. Okay, bye.